Hello everyone and welcome to Road to Space. I'm Eleonore Balenci and I will be your host for this live commentary on Arianespace's flight VV23 on board the lightweight launcher Vega. This is my first commentary. I am very excited. And with me in the studio to provide a deeper insight into tonight's mission is Samuel Rogez. Good evening, Samuel.
Good evening, Eleonore.
So Samuel, tonight two main passengers, THEOS-2 and FORMOSAT-7R TRITON from Thailand and Taiwan, taking to the skies for tonight's mission, entitled Golden Horizon, to illustrate the collaboration between the two countries as they embark on their celestial journey together. In additional 10 CubeSats are also piggybacking a ride aboard this mission. So Samuel, can you please explain in 2 words what happened during the first attempt 48 hours ago?
Sure, Eleonore. We have hundreds of sensors on the launcher and on the launch pad to monitor in real time the different parameters and status of the vehicle and the satellites. As it happens sometimes, one of these sensors had a measurement slightly above its threshold, triggering the hold-on of the final countdown.
And what was done next by the teams?
So first of all, and most importantly, our teams ensured that both the launcher and the 12 satellites were maintained in stable and safe conditions. Although they worked to understand the reason why the measurement was slightly above its threshold and to implement relevant corrective actions. This work is now completed and we are back to the final chronology.
So does this mean we will start back where the chronology was interrupted last Friday, a few seconds before liftoff?
Actually, no, Eleonore. Earlier today, we went back to the start of the chronology and we rolled over the different milestones that are planned during this sequence. And we are now almost 19 minutes before liftoff, with all parameters being green, as you can see on the control screen. So, all set for the launch.
And last but not least, can you share with us the main milestones of tonight's launch?
Yes, of course. So tonight's mission will see the following main steps. First of all the parameters must be green to authorize the liftoff. If so, we will initiate the final countdown 4 minutes before liftoff. Liftoff will be at 10 hours, 36 minutes and 25 seconds on the way to the low Earth orbit for sun-synchronous mission. The two main passengers will be separated 54 minutes and 22 seconds after liftoff, and finally the 10 CubeSats will be separated 1 hour, 43 minutes and 58 seconds after liftoff.
Thank you, Samuel. So we are all set for tonight's launch, and the teams in Jupiter are now focusing on final preparations ahead of liftoff. Our launcher is standing tall on its pad with its passenger big and small safely tucked under the fairing. Tonight's mission will be just under 2 hours long as Vega delivers our passenger into orbit. Samuel, could you take us through the key events we can expect during tonight's mission?
Yes, of course. So Vega launcher will take off from the French Guyana, so Guyana Space Center in South America, toward north. It will be first the ignition of the P-80, the first stage of the Vega launcher. The P-80 will push for about 2 minutes, and then a separation command will be sent to cut out the stage and separate it. This will be followed by the ignition of the second stage, the VV23, which will take over from the P-80 and continue increasing the launcher speed. It will then be separated, and this time it's the VV9 that will provide the launcher thrust. The VV9 will operate for almost 3 minutes, and during this phase we will jettison the fairing that protected the satellites as they pass through the atmosphere. Then the VV9 will be separated as well. Next comes an important step. It will be the first ignition of the upper stage, the AVUM, which is a rather special stage because it uses liquid propellants. It will be ignited and then it will shut down about 7 minutes later. We'll then have a long phase known as ballistic phase, which will lead us over Australia, where we will carry out the second ignition of the AVUM. And shortly after, we'll separate THEOS-2 and FORMOSAT-7R, and they will be released at the same time, simultaneously. Then after a short pause, we will reignite the AVUM upper stage for the third time to reduce the orbit altitude. After this burn, rather short, we'll have another ballistic phase that will take us over Cuba, where we can have the fourth ignition of the AVUM to circularize the orbit, and then separate the auxiliary passengers, the different CubeSats. Last step of this VV23 mission will be the final burn of the upper stage over Canada to reduce the altitude and avoid leaving debris orbiting the Earth.
Thank you, Samuel. Liftoff is scheduled in just over 15 minutes time. We will be hearing all the major milestones of tonight's mission announced by the Range Operations Manager, or the DDO, as we call him in Kourou, Axel Serges. Next to him is tonight's mission director, Bruno Hérin. Our two main passengers are due to separate simultaneously some 54 minutes after the launch, while our batch of smaller satellites, the 10 CubeSats, will be released around 50 minutes later. So now, let's first take a closer look at one of our first main passenger, FORMOSAT-7R TRITON.
TRITON, a Taiwan-developed weather satellite, also known as Wind Hunter, is a remarkable feat of modern technology. It is set to revolutionize the understanding of our planet, from the depths of the oceans to the height of the atmosphere. This mission payload, co-developed by the Taiwan Space Agency TASA and its academic partners, is the Global Navigation Satellite System Reflectometry, or GNSSR, an Earth observation technique allowing the satellite to take measurements of ocean wind speeds.
FORMOSAT-7 and TRITON embody Taiwan's dedication, pushing the boundary of space exploration. As we forge ahead, we are confident that TRITON's contribution will transcend borders, enriching Taiwan and the global scientific community. Together, we embark on an exciting era of cosmic explorations and groundbreaking innovations.
One of TRITON's key missions is to provide observations over ocean areas prone to severe weather systems. In an era where climate issues are at the forefront of global concern, TRITON plays a crucial role gathering essential data on sea surface roughness to retrieve wind speeds. Its real-time data transmission capabilities allow scientists to track events of natural disasters with unparalleled precision and to predict typhoon intensity, as Taiwan is greatly affected by typhoons every year. TRITON can provide nearly 70,000 observations in these areas in a single day.
The launch of TRITON demonstrates Taiwan has the capacity to independently design, manufacture, and operate satellites. Taiwan is one of the most reliable international partners in the industry of space technology.
TRITON's data collection is not just about understanding our planet, it's about safeguarding it for future generations.
And of course, we'll be taking a closer look at our second main passenger shortly. But first, we'd like to point out this panel, which we call the status panel, here in Jupiter Mission Control, and all eyes are focused on it ahead of the mission, Samuel.
Yes, it's an important panel. You show it on the right of the screen. It's a panel that summarizes the status of each of the systems and subsystems that are needed to achieve this launch. So it's very like a traffic light. If it's green, you can go ahead. If it's red, you'd better stop. For instance, what can lead to a red status could be the weather or the lightning risk, or if there is any trouble with the antennas, for instance, which are following the launcher. Of course, the launcher and the satellites have also their own parameters which are monitored, and they can raise a red in case there is any trouble.
And for now, good news, Samuel, we're all green, so
Yeah.
we are going to check out the other main passenger, Earth observation satellite THEOS-2.
Today on board Vega is THEOS-2, the latest advancement in Thailand's Earth observation satellite program, developed in partnership with the aerospace giant Airbus Defence and Space. THEOS-2 satellite, short for Thailand Earth Observation Satellite 2, is part of the second generation of Thailand's GISTA Earth observation system, succeeding the highly successful THEOS-1.
After operating the THEOS-1 satellite for around 15 years, Thailand decided to renew its partnership with Airbus with the THEOS-2 program. THEOS-2 is a very compact satellite providing images with a 50 centimeter resolution. The satellite is also very agile, meaning it can take many pictures over a large area.
THEOS-2 will capture very high-resolution images of the Earth's surface with great detail and accuracy. These images provide invaluable data for a wide range of applications, from agriculture and forestry management to disaster response and urban planning. In daily life, data allows for a precise and thematic mapping of cities. In crisis situations, the satellite can deliver real-time images to respond to climate emergencies in high-risk areas.
This achievement results from a 5-year collaboration between JISA and Airbus. THEOS-2 represents the next big leap in Thailand Earth observation capabilities with endless possibilities. THEOS-2 opens the door to promising business partners, both local and global scale. We look forward to the positive impacts of this very high resolution satellite for our communities, environment, and the entire world.
In an era marked by environmental challenges, Thailand, with its partner of choice Airbus, demonstrates how international collaboration can help to address global issues. THEOS-2 will help strengthen Thailand's national space industry and economy, making the nation one of the few in the world with sovereign access to very high-resolution geostrategic information.
And as we mentioned earlier, below our main passengers are 10 CubeSats, which will be released some 50 minutes after THEOS-2 and TRITON, thanks to a specifically designed dispenser called SSMS, able to accommodate pretty much any combination of passengers. Is that right, Samuel?
Yes, it's correct. So SSMS stands for Small Spacecraft Mission Service. It's a dispenser system which is really flexible. It was already flown on several Vega missions. The first one was in 2020 for the proof of concept flight with 53 satellites on board. And then in 2021, we had an hexagonal module supporting a main passenger and carrying as well auxiliary passengers. This time we have 2 satellites on the upper platform and 4 CubeSat deployers on the hexagonal module.
So 6 of our CubeSats were developed as part of the European Space Agency's In-Orbit Demonstration and Validation IOD-IOV program. Let's check it out.
The European Commission is currently at the forefront of pioneering space technology thanks to its in-orbit demonstration IOD and in-orbit validation IOV missions. The 6 satellites flying today will enable new technologies to be tested in orbit and gain flight heritage. The European Commission provides free-of-charge services for aggregation aboard satellites, launch and operations with the support of ESA. The IOD-IOV services not only drive scientific discovery, but also contribute to the growth of industries, to improving the everyday lives of individual citizens and to the resilience of our planet. They enable scientists and engineers to verify the performance of innovative instruments and provide students with invaluable experience in real-world space programs.
Great day for you, space. Today with Vega, we are boosting our scientific and technological leadership. Vega has embarked 6 satellites that have benefited from the in-orbit validation, in-orbit demonstration program of the European Union. In total, these are 9 experiments that we put into orbit from universities, research centers, and SMEs covering space, science, technology, population, or space environment. And coming from 5 countries, Belgium, Spain, Estonia, France, and Czechia. This is Europe by excellence. And indeed, we give the chance to new space companies as we are procuring the satellite from a very innovative company, EasySpace in the Netherlands. This is also a new territory for the Commission. For the first time ever, we have aggregated a set of different technologies and experiments on 2 CubeSats that we have called SynDeo-1 and SynDeo-2. SynDeo is the Greek name for putting together connecting, because this is what we do, building bridges across Europe.
Amongst the 9 IOD-IOV experiments on board Vega is S-Cube-2. This 3-unit CubeSat satellite, conceived by a group of students from the University of Tartu in Estonia, will gather scientific data on vegetation and test a new method to help keep space clean of debris. Another one is ANSA, a cluster of 3 satellites from the Spanish Institute of Aerospace Technology, INTA, working together to study and monitor the quality of water in the reserves of the Iberian Peninsula.
This is the first step. Our IOD-IOV program will continue to grow. Stay tuned.
And in addition to the 6 IOD-IOV CubeSats already mentioned in the movie, there are 4 more on board. Can you describe them to us, Samuel?
Yes, of course. So there are first NES for CNES, the French Space Agency, with a demonstrator to detect and localize interfering emissions on Earth. Then PRETI for Graz University in Austria. Then MAXAT for OQ Technology in Luxembourg. And finally, we have PVCC for Aerospace Lab and ESA. So these CubeSats embark a wide range of payloads and demonstrators.
Thanks for these details, Samuel. So on the ground in Kourou, the teams are hard at work as we prepare for liftoff. Very near to the actual Vega launch pad is the Vega Launch Center, the so-called CDL. All camera teams were out shooting there earlier today. It can be compared to a kind of cockpit on the ground. Can you tell us more about that, Samuel?
Yes, indeed, there are several teams. There are those located in Jupiter Building, which is a kind of control tower of the Guyana Space Center. And you have the Vega Launch Center, Vega CDL, a building called Pandora. And it's located in the Centre Technique, very close to Jupiter 2. Inside this building, you can find all launcher and launch complex operations teams, as well as the technical authorities, which you see on the screen. These teams manage and monitor all the operations leading to the launch up to the last second.
And now, Samuel, we are waiting for the DDO to announce the start of the synchronized sequence. And how do you think the team feel at this moment?
Yeah, there is clearly some stress because you realize it's quite a great achievement.
Attention pour la séquence finale, lanceur.
Concentration.
So yes, we just heard.
Just wait. We just wait to find.
Top à 0, moins 4 minutes.
And you have it.
Yes, we heard the DDO announce the start of the all-important synchronized sequence. It's one of the major milestones of tonight's mission.
Yeah.
But what does it mean, Samuel, and what's the next step?
It's the start of the synchronized sequence is an important step because it marks the start of the final phase that will prepare for takeoff and gradually give the launcher full autonomy to proceed with the liftoff.
So here it is, standing on its launch pad, but the first parts of the launcher arrived in Kourou back in June, right?
Yes, indeed. Most of the components of the Vega launcher arrived by sea, as you see, at the port of Kourou and were then transported by road to the Space Center. The first stage, the P-80, arrives on a mobile platform on the Vega launch pad. It's hoisted into the mobile gantry. And then we have the second stage, the VV23, which is lifted and assembled on top of the first stage, the P-80, as you see on the screen. Step by step, we are building up an assembly of solid rocket boosters. The third stage, the VV9, which you see on the screen, is hoisted into the building and integrated on top of the VV23. And then it's the AVUM upper stage, which arrives in its container. It's unloaded and then integrated onto the VV9 stage. As for the satellites, THEOS-2 arrived by plane in August and was prepared in a special facilities, clean rooms under very controlled atmosphere. And a number of operations are carried out in autonomy, and then THEOS was integrated on its adapter, filled with propellants. You can see the special suits we have used. FORMOSAT, on its side, arrived by plane also in July, and then followed a similar path with preparation, integration on its adapter, and propellant filling. The CubeSat deployers were integrated on the hexagonal structure below the platform. So for this mission, we had 4 deployers mounted on the hexagonal module. Then FORMOSAT-7R and THEOS-2 were integrated on top of the SSMS on the upper platform. And once the assembly was completed, it was enveloped in the fairing, which protects the satellites for the next phases of the mission. The upper composite was then transferred to the launch zone on a mobile platform. It's hoisted at the very top of the launcher and integrated on the AVUM. Several hours ago, we removed the mobile gantry, and we have now the launcher ready for flight.
So in a few seconds, the DDO is going to announce the 1-minute mark ahead of liftoff. All the markers are green to go, as you can see on the status. Samuel and I are going to interrupt our commentary now and let you sit back and enjoy the launch.
À tous de DDO, attention pour moins d'une minute. Top, à 0 moins 1 minute. À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P80, décollage. La propulsion est nominale. Acquisition de la télémesure par la station de Saint-Jean-du-Maroni. Les paramètres à bord sont normaux. Trajectoire nominale. Pilotage calme, propulsion nominale. Tous les paramètres à bord sont normaux. Pilotage calme. Tous les paramètres à bord sont normaux. Trajectoire nominale, pilotage calme. Séparation P80.
Samuel, oh my God, I am very
Allumage
impressed.
Z23.
While the launch, look, we can see
Yeah.
the P80 separation in live from the cameras. It's wow.
This is incredible.
Spectacular.
I am very impressed to have witnessed this launch
La
for the
propulsion est
first time
nominale,
in my
tous les
life.
paramètres
It's
à bord sont
crazy
normaux.
how fast it went.
Yeah. And so far everything is nominal, so it's very good. So in the THEOS-2 has ignited, so started the second stage phase.
Mhm.
So in a few seconds, he will have finished his job and separate from the launchers,
Mhm.
and then the
Calme.
third stage will continue to continue the mission.
So now we are waiting for the next announcement, and this follows the
Trajectoire
basic
nominale.
principle. When it comes to a space launch, you've got to shed as much weight as possible and as fast as possible, right?
Yes, indeed. The principle is to get rid of the useless mass. As you heard, we separate the first stage, then we soon separate the second one. And the basics is when an engine has finished burning and consumed its propellant, we just separate it. If we keep it on board, we would bring useless mass into space. And this useless mass is also costly in terms of propellant. So that's why we split a rocket into different stages to be able to get rid of the mass as we go, when it's no longer necessary.
So within 3 minutes, our launcher has gone from 138
nominale,
tons to
pilotage calme.
21. That means it's shed some 85% of its mass.
Yes, it's huge, and at the same time, we've gone from 0 to 3.6 kilometers per second
Séparation Z23
in
confirmée.
this time. So it's in 3 minutes. So it's crazy. So we have confirmation of the VV23 separation, and we should have soon the VV9 ignition. So we will just wait a few seconds for the
Allumage
DDO to
Z9
confirm.
confirmé. Séparation quoi?
It's just confirmed.
It's
Good.
confirmed, yes. So the fairing is off now. Why? Does it mean we don't need to protect our satellite anymore?
In fact, the fairing protects the satellites when the launcher goes through the atmosphere. Because clearly when we pass through the atmosphere, it generates quite a significant environment due to the aerodynamic friction. So for instance, it generates vibration or heat for the satellites. Once we are out of the atmosphere, these aerodynamic loads have been completely reduced. So we can just get rid of the fairing. Once again, the principle is to avoid dragging a mass that is not useful anymore.
And now looking at our 3D rendering of events, the animation takes into account the position of the sun and its reflection on our launcher. What we're looking at is an animation of what is expected to unfold up in space at this very moment. So this is as close as we can get to real-time imagery.
Yes, this 3D animation does not show the real-time behavior of the launcher, but it shows the predicted behavior of the launcher as it is expected. So it includes, of course, the trajectory, the velocity, the altitude, the ground track, etc., the different stages separation, but also the launcher maneuvers. It really shows the launcher orientation through time, including the orientation with respect to the Earth or to the Sun.
And tonight's is a sun-synchronous mission. What does that mean?
Yes, sun-synchronous orbit means that the satellites are flying over the Earth region always with the same sun orientation, so always at the same local time. It means you can easily compare pictures taken at the same time, but for different days. This is why it's often used for Earth observation satellites.
Trajectoire nominale.
But it also means we have to launch at a precise time and have no launch window.
Yes, indeed, because we target a precise time for the orbit. So, given the mission duration from the takeoff to the injection on the orbit, then we need to launch at a precise time to respect the final local time of the orbit.
And now, Samuel, we are waiting for another announcement, which is the Zephyr separation, the Zephyr-9.
Yeah, we are close to the end of the Zephyr-9 burning, so we call it queue de poussée, so the last part of the burn. So far, as we hear from the DDO, all the parameters on board are nominal, and the control of the launcher is very calm. So this is really good news. It means everything is on track and fine. We just had the confirmation.
The
for
range,
the Zephyr-9 separation. Yeah.
They just confirmed the separation of the third stage. So can you please explain to us what does it mean?
So it means we have finished the 3 successive significant acceleration flight phases, and now the launcher is flying very fast at 7.5 kilometers per second. So just to compare, it's 30 times faster than a commercial aircraft. So that's huge. And we are flying roughly at 200 kilometer altitude. And as for the previous stages, the Zephyr-9 is separated and the fall down is located in the ocean.
And now we are pursuing with the waiting for the Galliot signal and the Bermuda acquisition visibility like where everything is normal right now.
Acquisition de la télémesure par la station de Bermude.
Flight path tonight. Yeah.
So we are just acquiring acquisition from Bermuda. So now we are in contact with this station.
And Vega's flight path tonight takes it northwards across the Atlantic over the North Pole and back down, and along its journey, tracking stations along its path pick up the launcher signal. Who's in charge of this, Samuel?
So yeah, it's a CVI team, so it means Control Visuel Immédiat, or real-time monitoring, and they receive major flight parameters from the launcher all along the flight to monitor what's happening on board. It's a bit like the doctor checking the health monitoring parameters to verify that everything is fine on board. So the team in charge is located in Galliot on La Montagne des Pères, close to Kourou. It's possible, as you said, thanks to several ground tracking stations used for this mission, which are located along the ground track of the launcher. So first in French Guiana, then on Bermuda Island, and then Canada and Australia.
And so another step coming up is the confirmation of the first ignition.
perfect timing,
Yes,
Eleonore.
perfect timing.
Congratulations.
Thank you.
So we had the confirmation of the first AVOM ignition.
Yes, absolutely. What does this mean?
It means that this is the last stage of the launcher. It will deliver our first customers to their final destination with a very good precision. So the first AVOM boost is mandatory to reach an intermediate elliptical orbit. When achieved, the stage will just cut off. And during this phase, as we heard, we have Bermuda station, and then we'll have Gatineau, which will be acquiring data.
And we're calling it the first boost because one of the features of this upper stage is that it is restartable. It can fire and shut down up to 5 times. Why is this necessary?
This capability, this restart capability, allows to inject the different passengers in different orbits. It's like doing several stops with a bus. This is a major feature of Vega. Not all the launchers can propose such upper stage reignition capability. For example, today we'll have a change of orbit in between the 2 spacecraft separations, as requested by the customers, so they can go precisely where they want to go.
And this capability is further extended on Vega C?
Yeah, that's right, because the total number of upper stage ignitions is extended from 5 on Vega to 8 on Vega C. This way, we can reach up to 3 different orbits on Vega C.
So hugely flexible and adaptable service for the satellite, and so a massive advantage for multiple customers.
Indeed.
So obviously a mission like this is the result of years of collaboration between teams all over Europe, what's known in the space world as Space Team Europe. Space Team Europe is an ESA-led initiative that brings all space actors under the same umbrella, with no barriers or boundaries between companies.
Yes, it's a very complex preparation. It implies years of work for many people from various companies in different countries around Europe, across Europe.
Yeah, so for a launcher like Vega, where do all the parts come from?
Yeah, let's take a few examples. There are parts coming from all over Europe, as I said, with teams working all together. If we come from top to bottom, the fairing is produced by the aptly named Beyond Gravity in Switzerland, the dispenser by Saab in Czech Republic and Italy, the adapter and the AVOM structure by Airbus in Spain, and the boosters, of course, by Avio in Colleferro in Italy. So here, I would like to take the opportunity to say a warm hello and congratulate all these teams for all what they did to make this launch happen.
Yes, congratulations to everyone. It represents years of work. And now on the ground in Kourou too, there are many different teams involved. Some people live there year-round, others spend weeks or months on site ahead of each mission. Our camera team went out to meet them. We are going to take a look right now. Let's check it out.
Paramètres à bord normaux.
Attualmente mi occupo di coordinare e pianificare le attività delle squadre impegnate sulla fabbricazione e quindi integrazione degli stadi a propellente solido, nello specifico del P80 per il lanciatore Vega.
Moi, en tant que responsable ensemble à mon équipe, on a le rôle de certifier la conformité du chargement qui a été utilisé pour les premiers étages du vol Vega VV23, c'est-à-dire les P80 F21.
In Avio sono un tecnologo del gruppo di assemblaggio, integrazione e test. La campagna di lancio ricopre un ruolo di responsabile del cosiddetto burrone, ovvero mettere a disposizione e gestire tutta la documentazione operativa e fornire subtecnico durante tutte le operazioni di integrazione meccanica e pirotecnica.
Alors, pour la campagne Vega, je travaille avec Avio conjointement. Avio, c'est l'industriel qui est responsable de l'intégration du lanceur, pour que les opérations sont réalisées conformément aux spécifications qui permettent de garantir la qualification du système de lancement.
Allora, in questa campagna Vega rivesto 2 ruoli. Sono assistente avionizione e quindi seguo tutte le attività di test avionici sul lanciatore, quindi la gestione delle risorse, l'analisi e la corretta esecuzione dei test che vengono eseguiti e la loro pianificazione. In più rivesto il ruolo di responsabile di tutte le attività sul banco di controllo, la gestione delle persone e il corretto funzionamento del banco, perché è la più importante e necessaria nella campagna di lancio.
Alors, je suis le responsable des ensembles de préparation satellite au centre spatial. C'est-à-dire que je suis responsable des bâtiments qui accueillent le satellite. Derrière moi, ce qu'on voit, c'est une salle où justement va être préparé le satellite dans un premier temps, et puis rempli. Après quoi, on va pouvoir transporter le satellite vers la zone de lancement où il sera intégré.
Les paramètres à bord sont normaux.
Alors mon rôle, C'est simple en fait. J'accompagne nos clients satellites depuis la fin de leur phase qui est dite standalone, c'est leur préparation de leur satellite, jusqu'au lancement. Donc cette phase, elle s'appelle le plan d'opération combiné. En fait, c'est l'intégration des satellites sur le lanceur. Toutes les structures qui vont permettre de l'intégrer sur le lanceur. Donc nous sommes à J-5, à 5 lancements, et ce jour est dédié au transfert du pack. Donc le pack, c'est l'ensemble des sites sous coiffe vers la zone de lancement. Et nous avons la chance de voir le pack qui démarre. C'est évidemment un événement majeur de la campagne. Et j'en ai les poils qui se dressent tellement ça me rend heureux qu'on en soit arrivé là.
And yes, this video illustrates a real teamwork. And now we are waiting for confirmation of the first engine cutoff, which will signal the start of our first long ballistics phase. So what does this ballistics phase mean for our launcher and all passengers?
Once the AVUM engine shuts down, the launcher and the spacecraft are on an elliptical orbit with no engine thrusting, and it will last approximately 36 minutes. So this coasting phase or ballistic phase will enable us to reach an altitude above 600 kilometers. During this ballistic phase, the launcher will keep its momentum and continue its path around the North Pole and then down to Australia. So we had just confirmation of the first AVUM cutoff, which is very good news. It means we are at the right location expected.
Absolutely. So, Samuel, one day we'll be sitting here commenting on the new upper stage engine, which will take over from AVUM and which is currently being tested.
This is the M10 engine, which we see at the screen, and it's developed by Avio with a thrust class of 10 tons. It's the first of its kind to be successfully tested in Europe. It's made with additive layer manufacturing, and it's part of the development of Vega E launcher, an evolution of Vega, a project coordinated by the European Space Agency with the goal to qualify this next version starting in 2026. It uses oxygen and methane as propellants, and it was successfully tested in Avio's test facility in Sardinia, as you see the videos, last year and since August this year. Recently, we achieved a firing test of 340 seconds and changing several times the propellant mixture ratio, which was a key because if we can modify the level of thrust of the engine, then it's a really key step towards reusability.
Thanks for that, Samuel. Can you just take us back through the mission so far and where we are now?
Yeah. So Vega liftoff took place from the Arianespace Center. It was triggered by the ignition of the P-80, which is the first solid stage of Vega launcher. The P-80 stage pushed for about 2 minutes, and then it was separated with the separation command, and the stage was just cut from the launcher. It was followed by the ignition of the second stage, VV23, which took over from the P-80 to continue increasing the launcher speed. It was then separated, and this time it was the VV9, the third stage, that provided the launcher thrust. During the VV9 phase, which lasts for almost 3 minutes, we had the separation of the fairing that protected the satellites as we passed through the atmosphere. Then the VV9 itself was separated as well. Then we had an important step with the first ignition of the upper stage, the AVUM, the one equipped with liquid propellants, and it lasted approximately 7 minutes, and then we shut it down just recently, and we start the long phase we know as ballistic phase that will lead us over Australia, where we'll carry out the second burn of the AVUM stage, and shortly after separate simultaneously THEOS-2 and FORMOSAT-7R. After a short break, we'll then reignite the upper stage for the third time to reduce the orbit altitude, and this burn will be very short, and after we'll have another ballistic phase to go over Cuba, where we can have the fourth ignition of the AVUM and the separation of the CubeSats. The very last step of this mission will be the final burn, the fifth burn of the upper stage over Canada, to reduce the altitude and avoid leaving any debris on the orbiting the Earth.
Thank you very much, Samuel, for these details and very important steps. And now we are waiting for the loss of signal in Gatineau. And during this ballistic phase, if we lose contact with our launcher, this is completely normal, right?
Yes, indeed. During the ballistic phase, it's normal that the ground tracking stations are not able to maintain the contact with the launcher as we go up to North Pole. And yes, we have just confirmation of the loss of Gatineau, so which was expected. And as soon as we, in fact, memory on board is recording all the flight data we have, so it's not an issue. And as soon as the next ground station will be in visibility, so it will be New Norcia in Australia, then the data will be downloaded. So this way, all the information of the flight can be available.
So Samuel and I are now going to interrupt our commentary for the next half hour during the first ballistic phase. You can follow the mission here on Road to Space thanks to our state-of-the-art 3D imagery, which shows you in real time the launcher's expected behavior up in space. The second AVM boost will occur a couple of minutes later and will be followed by the separation of our two main satellites at H plus 54 and 53 seconds. The CubeSats will be released some 50 minutes later. So Samuel and I will be back at H plus 50 minutes. See you soon.
See you soon.
And welcome back to Road to Space. So we're about to reach the end of our first extended ballistics phase. We're just about to resume contact with our launcher in just under a minute as the ground tracking station of New Norcia regains visibility. Samuel, what's happened in the time we've been away?
So it's good, in perfect timing, we have the confirmation of acquisition by New Norcia station. So during the ballistic phase, the launcher has kept its momentum and continued its path around the Earth, so toward the North Pole and down to Australia. During the ballistic phase, as we said, there is no engine burning, so we just keep on the momentum and reach the following steps of the orbit. So here we are now in contact with New Norcia.
And we see our colleagues in CVI who are in direct contact with Vega.
Yeah, it's the team in charge of the real-time monitoring of the launcher. So we see a number of my colleagues who have been working for years now on this mission. So Justine Tenil here, Armel Girard as well, and the Avio colleagues. So they are checking the onboard parameters in live, and they are monitoring that everything is fine. And it's possible thanks to the different stations we have. Mm-hmm. So we have just in live, while I was speaking, the second Avum ignition confirmed by the DDO.
Yes. Can you remind us, Samuel, what's the purpose of this second boost?
Yes, the purpose of this second boost is to circularize the orbit, raising the perigee, which is the lowest point of the orbit, in order to reach a circular orbit close to 600 kilometers, which is the target altitude to release the first passengers. Mm-hmm. So we just have the ignition of the Avum, and it will last around 1.5 minutes, so it's rather short.
This simultaneous separation is a specificity of this mission, right?
Yeah, then after the second boost, we'll have the simultaneous separation, and it's rather tricky because we'll have a very precise orientation with respect to the Sun. This is to avoid that the Sun illuminates sensitive areas of the satellite, and we'll have different velocities. THEOS will be separated quicker than FORMOSAT. This is to ensure a correct distancing of the satellites once they will be in orbit. And yeah, this separation was quite tricky to be studied and verified. It implied rather complex studies from both Arianespace and Avio teams to be sure that all goes perfectly. And here we had just the confirmation of the extension of the Avum. So it means we are exactly on the right orbit. The separation normally should start soon.
Exactly. So back in Jupiter, we can only imagine the concentration as everyone awaits the result of years of work. It is indeed a great technical and human adventure for the people involved in this launch.
Indeed, yes. For this mission, it has implied years of work. It's true on launcher side, but it's true also on satellite side. So they've been working for years on these satellites. So here is really a key step we are waiting.
Les paramètres à bord sont normaux.
So now waiting for the last announcement from TDO.
So we have a slight orientation maneuver before, and then once we are correctly aligned,
séparation THEOS-2 et FORMOSAT-7R TRITON.
For the confirmation. And there we go.
Oh my God,
nice.
That's a great news.
We can see the teams.
It's very nice to see these images of the teams at Jupiter Center.
You can see Bruno Hérin, who I guess is a bit relieved.
Yes, big round of applause there.
And
nice moment
and
to
Stéphane
share.
is being equipped. So I guess we'll be discussing with him soon.
Yes, they are cheering up right now, and we might be able to have a few words from Stéphane, and we know that there is a high level of concentration.
Here on the screen is Adriana Marcello, project director for THEOS and FORMOSAT satellites, so with Airbus customer on her side, so I guess she's really relieved after years of work with the teams.
And while we're waiting for Stéphane to be interviewed, what will you remember from today's launch?
I mean, it's a bit special because I was involved in the first steps of this preparation of this mission. So for me, yeah, it's really a chance for
it's
me
unique and special,
to have been involved and see the conclusion, the outcome, and being aware of the teams that have worked so hard on this, and to see THEOS and FORMOSAT-7R correctly released. It's very nice. I think Stéphane is ready.
And Stéphane is with us, CEO of Arianespace, live from the Jupiter Control Center. Hi, Stéphane. So what just happened? Where do we stand now?
Yes, so we have now reached a key milestone of this mission because we have successfully separated on the right orbit our two main passengers, THEOS-2 for G-Star, built by Airbus Defence and Space for Thailand, and FORMOSAT-7R TRITON for the Taiwan Space Agency, TASA.
And now, Stéphane, what's next ahead of us?
So in now less than 50 minutes and after 2 more boosts of AVUM, we will separate our 10 auxiliary passengers. You know that this mission is embarking very innovative satellites, CubeSat. Some of them are for the European Commission, so we need now to go to this final step for success of the mission.
Tous les paramètres à bord sont normaux.
Of course, we hope so. And to conclude, maybe one last word to address?
Yes, for sure. I would like to thank our customers for their trust, Thailand, Taiwan, Airbus Defence and Space, the European Commission and the CubeSat, for which we are now about to deliver. And for sure, I would like to thank all the teams for what have been already done tonight. The team of Arianespace, for sure, but Avio, our prime for the Vega launch system, Isaac, Ness, and all the teams who have worked for this tonight mission.
Thank you very much, Stéphane, and again, congratulations.
Thank you very much.
Great news for this successful first part of the mission. The release of our 10 CubeSats is scheduled in about 45 minutes. The separation is scheduled to start at H+1 hour, 43 minutes and 58 seconds. This will take about 2 minutes. That's quite long in space-time. Can you tell us why, Samuel?
Yes, of course. So it's for the CubeSat, it will take 2 minutes to separate the 10 passengers we have. This is due to the fact that the separation sequence is a bit long. You have to know that for separating the CubeSats, the launcher is oriented in a very special manner. This is to obtain different velocities for the CubeSat once separated. So once we'll be positioned, we will open the first batch of deployer doors to separate the first CubeSats. But you have to understand that one deployer has 4 doors to open. So we need to wait a bit, so between 30 seconds and 1 minute, between each door opening to ensure that there is sufficient distance in between the CubeSats and avoid any risk of collision once in orbit. This is why the overall CubeSat separation sequence can last 2 minutes in total.
Thank you very much, Samuel, for this last detail as we are closing our launch show tonight. Well, I have to say thank you to everyone. You can follow the rest of Arianespace's mission VV23 here with us on Road to Space, thanks to our state-of-the-art 3D imagery, which offers a recreation of the launcher's expected behavior up in space. Thanks again, Samuel. It was a pleasure commenting with you.
Thank you, Eleonore. It was really also a pleasure for me to comment this launch live with you, and I would like again to thank all of the team members which were involved in this launch.
Yes, thanks to the whole team that has worked so hard to bring you this live event, and to our translators Lucille and Damien.
And I guess we can wish all the best to the CubeSats passengers that are still on board waiting for their safe separation.
Of course. Enjoy the rest of tonight's mission and goodbye.
Goodbye.
Le pilotage est calme, les paramètres à bord sont normaux. Allumage, troisième boost à vous. Extinction, troisième boost à vous.
Tous les paramètres à bord sont normaux. Tous les paramètres à bord sont normaux. Fin de réception par la station télémesure de New Murcia.
Acquisition d'un télémesure par la station de Bermude. Le pilotage est calme, tous les paramètres à bord sont normaux. Allumage 4e boost à Voom. Quatrième extinction à Voom. Acquisition d'un télémesure par la station de Gatineau. Séparation PVCC, Answer F2 et CSC1. Fin de visibilité Bermude. Cinquième allumage à vous. Pilotage calme, propulsion nominale. Les paramètres à bord sont normaux. La trajectoire est nominale. Extinction du dernier boost à vous. Les paramètres à bord sont normaux. Passivation des réservoirs. Perte de la télémesure par la station de Gatineau.